So, today we are back with some more portable power station action. This is the EcoFlow RIVER 2. And, well, I suppose the main thing about the new versions, which is obviously the 2 series, because there is a River 1, this is the River 2, is that the features from the top tier stuff are slowly trickling down. And by features, I mean Bluetooth connectivity. So if we were to turn this bad boy on, I'm just going to start my screen recorder right now, in here somewhere. Go! Right, so let's try and connect to this power station, because it's like the first thing we're going to do. We want our EcoFlow. I've already been through and signed up with the app, and, well, you can see there that it's automatically found the River 2, so we can now add it to our system. And then we just need to put our Wi-Fi network in, which is, I'm going to give it my home network. Okay, so that's our first failure. So as we can see there, it says your Wi-Fi is a 2.4 gigahertz network. Well, it's both. Because I have, well, like most people nowadays will run their network in what's on some routers is called smart mode, where the 5G network and the 2.4G are joined together, and it's up to the devices to decide how they connect it. And, well, that's not going to work here, is it? Because it's totally not doing it. So we'll just use without internet then. And so we've kind of got a connection between the phone and the thing on a local, I presume, Bluetooth network. Is it Bluetooth? No, it might be, or some sort of Wi-Fi. But anyway, I've got 31% left in the battery, which is because I haven't charged it. Right, so, yeah. So I should be able to take the power cable, which, strange enough, says EcoFlow RIVER series only. So what is it about this power cable that it only works on the River series? Has it got perhaps a small fuse? Right, on the back of the unit, that's where your inputs lie. Mains power, and then we'll call it the multi-power for your 12 volt, solar, whatever you want. Somewhere like between 8 and 30 or more than that. I will look it up in the manual for you. Wait, it might say on here, input. Oh, does it? AC input, DC input, MD? No, I'm gonna have to look up the manual. Anyway, plug it in. Jam that in there nice. Right. It's now charging. Hopefully we should be able to see input on the screen. There we go, input, and basically in real time, we'll see it on the phone. 200, 300. We'll normalize it about 330-ish volts. So in 42 minutes, that will be fully charged. And if this was on the internet, we'd be able to check the status of this from anywhere we have the internet, if this is connected to the internet. Then again, a power outage, you might have your router up and running. You might not. Right, how do you turn things on and off? Okay, that's good. Wait, did that show a temperature there? 68 degrees Fahrenheit. Fahrenheit? What is this, the Dark Ages? Where's temperatures? Yes, please. Can we have degrees C? Unit weight? Can we have that in kilograms so it makes sense? Any firmware updates? Connect network. The device is not connected to the internet. Ah, great. So I'm going to have to go and make a 2G, 2.4 gigahertz network. Yeah, okay. Wait, can you change that? Oh, you can turn the AC charging speed up and down. That's actually quite a handy thing. So if you're powering this from another power bank with a limited power output, you could actually bring that power down so you don't max out your other power bank. Interesting. Car input, 8 amp, up to 8 amps, which we'll be testing in a moment. Yeah. Okay. Does it actually tell us anything about our unit? Is there any, is that it? So at the moment, the unit is charging. You can see there we've got 335-ish input watts. And it does have a fan. The intake, there's a kind of grill hole on the front here, and a fan output on the reverse. There's the output fan. It's pretty quiet. Well, it's pretty quiet compared to some of the other ones, should I say. It's not as loud, but it's not like loud and annoying. Obviously we should have here a DC output, which is 12 volts, and it says up to 8 amps, and we've got an AC output, which is upside down, but that might be a good thing, because then your cable's not coming down and trying to do a harsh bend. You can just loop it up and over the top. Now, as for the AC output has a claimed of, where are we? 600 watt. I think is that like AC output boost. 300 watt running and a 600 watt like normal, well, boosty. 600 watt boost and then 300 watt normal running. So not a huge inverter. That's the one thing I would like to see. Like, by all means, right? Make them small with smaller battery packs that maybe only last a little while, but put big inverters in them. Like, there's things which use a lot of power, but I only need to run them briefly. I don't know, like a compressor or a drill or something with, you know, a big, heavy, you know, startup load, so you can have a huge startup load and then just put big inverters in them. Just put bigger inverters in, please. Right, okay, before we actually do any tests, what I'm going to do is take it apart, because that's what we're doing here. Do you think there's, I mean, the construction looks like it should be top off, and there's 4 definite covers there. Oh, it'd be nice if they built it like that, if they actually made it in such a way they could take it apart really easily. So, let's get a pick, get these off, see what's underneath, and then let's get inside, and then we'll put it back together, and then we'll run some tests. I have taken my pick. Let us see what's in here. Yay, it's screw heads. Plain, old-fashioned Phillips screws. Happy days, right. I like that they've made it clips that don't just like shatter into a trillion bits when you start to take things apart. Right, I'm just going to read out some of the stuff in the instruction manual while I take these screws out. So this has a capacity of 256 watt hours. It weighs 7.8 pounds, whatever that is in kilograms. AC input, as we saw, 8 amp max charging. DC input, also 8 amp max charging. USB-C input and output, maximum of 3 amps. Where's the DC? DC output, maximum 100 watts, which is 8 amps. And AC output 300 watts running at a surge of 600 watts, which is actually pretty good if you think about it, because most normal inverters, the surge isn't twice as much as the actual running. It's, you know, it's like 1.5 times. The batteries inside are LFPs, the lithium iron phosphate cells, as usual, you know, the 3,000 cycles and 10 years of whatnots, all that kind of stuff. And there's a bit more for connecting solar panels. But yeah, so the main thing is, it's got the LFP batteries, it's got fancy Wi-Fi, which is nice. I know some people don't understand why would you want to have Wi-Fi, but the point of the Wi-Fi is so even in the smaller units, you might not be where it is, if you know what I mean. It might be outside or further away from you, and rather than going and looking and checking unit, you can just get your phone out and see what the unit's doing, what its runtime is, etc, etc. Right, I've got the screws unscrewed. 1, 2, 3, 4. 4 came out. I'm now going to go and get a spudger and try and pop this plastic open. One moment. Spudgers. So, the River is the smallest EcoFlow thing they make. They make some absolutely monster-sized units. And from what I've seen online and read, EcoFlow are like a top-tier producer of power supplies. Some have even called it the Apple of, you know, portable power stations and battery whatnots. Right, we're about to delve inside. So I'm going to bring you over a bit. Bring you over. And then we'll zoom you down. Ah! Inside. Sorry. That is controls, please. Get a bit closer, like that. And then let's take the lid off. Da, 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 da. Lid off. Holy baby. That is a lot of bits. Right, come now, and let's go for a look. Boop. Oh, well, I can see everything's nice and shinily conformally coated. Does that show up in the camera? The circuit board is very, very shiny. There is a lot stuffed onto that board. Man, I'm not even going to pretend to know what most of it is. Oh, what's this? What's this strange earth-coloured wire? It's an actual earth connection. That means that this actually, like the power oak, actually has a coupled earth. It's actually attached to something. I don't know what it's going to attach to anything else because this is an absolute plastic body. There's no metal components to be touching, but it's nice that it is attached. And we'll have to actually make sure, put our testy plug in the plug hole and make sure the earth is actually connected to something else. Right, well, I suppose we should see how much further in we can get and see if we can get in to see the batteries. Let me zoom you back out a touch. Right, there's a lot of screws and whatnot. So what is holding? What do we think is holding what in? That is oh wait, that's not molded. That is just a. Oh, that's nice. What a handy feature. Can I just unplug that, please? Nice. Fan module just comes straight out. Oh no, they have put vibration mitigation in. It does have a foam pad at the bottom and it gets pressed on the top, so that will not vibrate. Good, good, good. I can see what appears to be large battery taps in the bottom. On this board does actually have BMS written on it, so I presume that'll be the battery management board. Now, do you think this is just going to lift out in a oneie? Or we're going to have to... How would they have put this together? Because that board is underneath this board. And all this, that bit's hot glued in. That's hot glued into place. Have they made this so you can't take it back out? That's stuck in. I want to see the batteries. I want to get to the battery pack. I'm going to have a fight with this off camera and I'll bring you back once I've worked out if I can get it out. Right, this black boy here, that was over those two terminals and they just like slot out of place. You just lift them and slot the thing and that. Hopefully I can just unplug that and then that lets us take the front cover up and over. And we get to have a look at the other bits. There's a lot of control-y circuitry in there. Right, okay. And that still, oh no, it lets us into the bottom area where the batteries live. Oh, they're not 18650s. They're huge. They're huge batteries. Oh, right, we really need to get further in now. Okay. I'm going to spend longer unplugging things and get this top board off of there. Okay, I've removed all the small screws that should be holding this board in, so we should be able just to lift this board out in a oneie. And, oh wait, there's a connection here. One moment, please. Let me put that back. Let me undo this bad boy. Slot one here, undo that. And then that should let us lift this bit out. Nice. Ooh, and a lot more conformal coating. Let me zoom out a little bit for you. Zoom out. And, well, hopefully you can see here there's a danger, and that must be the high voltage AC side, and this must be the DC side. And there's a lot of separation, but not a cut gap separation, but definitely some separation. And, oh, it's actually using, wait, can I show you on the, see there, the massive positive and negative. It's actually using those two posts there that come through. That's actually connecting the lower board, the BMS board. That's actually what's connecting through to the top. Nice. This is got a weight to it. This is some heavy components on there. Nice heat sinks. They sound dense. Dense is the word I was looking for. It's a very dense board. I'm not even going to pretend. I know what some of these components are, but what they're doing on this board, hey, I wouldn't even be guessing. I would just be literally, well, I would be guessing. Literally, I would be guessing. Oh, it's a good time to check plastics. Does it say what kind of plastic it is? No, I don't see any markings on it. On this bit, anyway. Alright, I'm going to set that there. It's a nice plastic, though. Maybe ABS. Feels dense. I said dense again. That's twice I've said dense in the same video. Right, that leads us into the battery thing pack, which... how are you supposed to get this out? Presume it must come out. But I don't know what's holding it in, because I can see there that the two tabs at the top, those two are definitely soldered, you know, brought up, folded on, and then soldered onto the board in place. There are more screws to undo it. And there's all these tabs are also soldered in place. Like, you put your board on top and then... Oh, wait, I see how you get the bars. It's blazingly obvious, David. There's like 4 massive sets of screws down the side you just have to undo. Right, so if these aren't 18650s, what are they? Because they are ginormous from what I can see. And it's not ginormous like 18650s inside something else, because they're round. What are they? I am very curious. Leave a comment down below if you think this will still work once I put it all back together. Right, we should now be able to lift the whole battery pack out like that. And there they are. Look at the size of them. There are 4 giant cells. Unmarked. Oh, there, the sides I can see are unmarked. And, well, from that arrangement I can see positive, negative. They're huge. Suppose I should check what voltage one of them is. Please, sit there. Right, does this plastic say what kind of plastic it is? Again, I don't see any... Oh, what's number 7? What's the number 7 on the plastic things? Let's Google that, as well as testing the voltage of there. Right, stay. Let me get my voltmeter in. Let me scooch you up bed a bit. Let's have... let's go that way and try and knock as many screws off as possible. DC volts. So there's a battery positive and a battery negative here. Let's try that. So that gets us 13.21. That must be... it's all together, so that's its total voltage. 13.21. 13 divided by 12, by 4. 3 4s are 12s. These should be like 4 volts each. I've got no idea if I'm actually on the correct polarity. I wasn't paying attention. What we got? 3.3 volts. So 3 times 3.3s. And these massive... what size? What size are they? Let me get a measuring device. Stay. Literally kicked the bucket there. Right, approximate sizes, because I can only do approximates right now. About... I've run out of caliper. 1400? Not quite 1400, a 13 something. 1300-ish. It isn't quite 1400. The box is 1400, so it's got to be less than 1400. 1400 by... 40? It's definitely 40. 1400 by 40. Yep. Wow, these are... Again, but strangely, they're not very heavy. I mean, they're heavy, but they're not power oak heavy. They're just kind of normally heavy. So, 4 3-volt batteries. And a nice BMS pack. So if I put that... Wait, is that the right way around? Is that the right way around? I'll put that back in there. I like that. So the posts, where's the... it should be positive and negative, so we should have... we've got 12. Well, that's interesting. So from the back... wait, we've got battery positive and battery negative here of 13.2 volts. And we've got a positive and a negative here. But they're not active. Ah, the BMS must be able to turn them on and off. That's interesting. Nice. Right. What I shall do now is put it all back together and then we'll plug some things in and test it. Well, it's all back together and I have to say I am very impressed with the modular style of design and implementation. I'm not saying I could fix a lot of the surface mount components, but I'd be happy to, you know, be able to take the lid off it and at least see if, you know, if any of the capacitors have popped or a relay that's not relaying anymore or anything like that. I can actually get in and get at them and take them out, or perhaps even the, that appears to be the mains input fuse is on that part. Like, these are all things that I could get in and check and test and possibly repair. As for the other surface mount components, if any of them die, I am out of my depth and would have to send it away to someone who could repair circuit boards and have it that. But at least in that sense, I could then again still take it apart and take a circuit board to somebody and say, can you have a look at that for me? Right, moment of truth now, I suppose. See if it turns back on. Hey, not a problem. And no smoke. Ooh, there's LEDs on the board. There's... right, let me bring you in with the the camera here. So we've got a little green LED flashing away in there, and we've got another one down under the that white plug there. Where is it? Can you see it? Chirping away down in there. That was like 2 status LEDs. Wait, has that other one gone out? One of them has gone out. Okay, right, well. Nothing has caught fire or exploded or anything like that, which is good. And right, well, the main test that I wanted to do now from now on with these heaters is the diesel heater test. If this will power a portable diesel heater. I'm going to put these last couple of screws in and then set up the diesel heater and we'll fire it up, or we'll attempt to fire it up. We have the H-Gallery all-in-one diesel heater in a box. Right, I could just show you it being a diesel heater in a box. It is literally a diesel heater in a box, being portable. Should run off one of these 12 volt cigarette lighter socket. I wish that exhaust didn't rattle like that, but it does. I'm going to plug that in there and turn on the DC output. Okay, the DC output is on. I'm now going to use my phone and the H-Gallery app. Okay, the heater is currently in standby. We shall fire up, and you press and hold. That lights up all the bars, and then it should fire up. Start heating indeed, my friend. And then, down there, we should see the wattage. We're going to need a lot more current than that to start. But as long as it can maintain, I'm expecting more watts. I wish it showed you the output voltage, because that was the problem with the Power Oak, was that although it could deliver the current, it dropped the voltage way down to like useless, and then it didn't work anymore. So I have set my voltmeter up, and I'm going to do a voltage reading. Oh. Oops. Has that got a terrible connection? Oh, it does. It's got a very springy. That's annoying. Right. Let's reconnect to the heater again. Right, zoom you out a bit until we see what's happening. So we had a failure to start there the first time because this hasn't got a very good connection It's very springy inside and wants to push the thing off the contact at the end. I want to get the voltage of what it's doing while it does it. Right. So right now we have an output of 12.7 volts. 12 point. We've got voltage of nothing just now because I've moved my probes off the thing. Stab in. Stop it. Has this got a stand? It does. Right. Flip up stand. Can you see on the screen? Can I see? Yes. Right. 12.7. Still plugged in. Still turned on. Let's use the phone, which is still recording in the background. Right. Turn on the heater this time. Go. Start heating indeed. Now what we don't want to see is the voltage disappear. That is absolute garbage. EcoFlow, I expected much, much better of you. There's no 0.6 volts is not going to start a diesel here. I know this for a fact. Well, that is very, very disappointing. And no, I shan't be editing that out because that's a thing, it's a test, and it has failed that test. So, the EcoFlow will not run your portable diesel heater because it does not actually have an 8 amp output. I don't know how to tell that to them, but what that 8 amp output is lies. Right, okay, so our DC output was a bit of a failure, so we'll turn it off, and then we'll put our now upside down testy plug into the AC and turn it on. Where's the button? Go. Nothing. Don't know what no lights mean. I should surely it's not output dependent. Surely I would have like all the time. No. Ladies and gentlemen, the AC output works 100% better if you plug it back in. Ta-da! AC output will now work. What an idiot. Sadly, that won't fix the DC problem. That's its own separate beast. Okay, this time we will turn it on. We'll plug in our upside down testy thing. And we've got a single pulse, which is should be missing earth. Well, we know it's there, but what's it going to attach to? Stop beeping. So only thinks it's missing probably because it's not coupled to the neutral side, which doesn't, as I say, it doesn't make any difference because this is a plastic box. It does not attach to ground. Right, we'll try our compact fluorescent lamp again. This time, obviously, it will work because plugged in reasons. Turn that on. Turn on lamp. Ta-da! One lamp. And it is consuming. I presume it'll take a moment for it to work out how many watts this lamp is actually consuming. It says it's going to last for 4 hours, but the output is nothing. I wonder if it's so low. What wattage is this? Does it say? 13 watt. So it says 13 watts. Let's unplug it and put our power thing in. Wait, let's go that way up. Plug that in. What we got? 232 volts. No amps because it's not running, and that's not the wattage I want to see. I just want to see running watts. Let's plug this in. Our light is lit. Okay, 10 watts. Slightly disappointed that the display on there is not showing 10 watts. Next question. Does my phone display the current wattage? Where are we? Nope, it's not a heater. It's a thing. Disconnected. Well, reconnect then, why don't you? It's not on the internet. That one, 38%. AC output, still 0 watts, so I'm guessing it. But see, that's the weird thing. So it knows that it's got 4 hours of runtime on that lamp, but it won't actually show the output. Wonder why. I would expect you to be able to turn the outputs. Ah, you can't turn them off if you go to output. If you were looking at the inputs, that's why it won't show you. But then it also doesn't show us less than. Right, let me just put my screen capture back on again. Okay, so that's the outputs. We can see the outputs. That's the inputs that we were looking at previously and getting it wrong. So from here, we should be able to turn off that lamp. Ta-da! Okay, that is a handy feature. Being able to turn, that on and off remotely. And the DC, turn DC on and off remotely as well. Just a shame the DC output doesn't match what it says on the tin. And the USB-A-C you don't get to turn off remotely, but you can see if they're doing anything. I don't have anything USB-C except this phone, and I don't have a USB-C cable out here with me. Yet. Anyway, right, that does us for lamps. Turn the lamp off. No, press the switch. Oh, much better. Well, it's final thoughts time on the EcoFlow River Delta. It's a very well-made unit. I like the modular construction. I like the fact you can just take the lid off and you're basically in at the guts, a few screws, and you're right down to the giant batteries at the bottom of it. That I've said, this is the smallest of the EcoFlows they do in this series. They do much larger, much larger, like whole house powering sized versions of their power banks and whatnot, and they look very, very nice. Not that we're ever likely to be able to afford one of them, but this is a nice little unit. Well, it is a little unit. It is a 300 watt power supply, good for charging laptops, charging cameras, running small appliances, anything with a 300 watt running and less than a 600 watt startup. I am, however, very, very disappointed in the performance of the DC output. So I don't know what you would be able to, because tire compressors, they run, granted, they really don't care about voltage that much though, so you'd be able to plug your tire compressor in, turn it on, the current would come up, the voltage would drop, and all your tire compressor would do is just slow down. But what it means for a diesel heater is, you plug it in, and if the voltage drops away down, the glow plug doesn't get hot enough to start the ignition, so it just doesn't light. So I'd like to know where they got their 8 amp rating from, because we didn't get 8 amps out of that. We didn't get anywhere near 8 amps, and if we did, it dropped the voltage all the way down to 8 volts, which is not enough, I'm afraid. So in that respect, it's the same as the Power Oak, where it just drops the voltage to kind of keep the current in check. Other than that, it's got only one USB-C. 2 USB-As and 1 USB-C. I would have expected more USB-Cs on, well, a modern appliance like this, because even now with Apple being forced to switch over to USB-C, everything from now on will likely be USB-C. And on the back, you just have your mains in and your multi-plug, whereas the 12 volt boy, 12 volt plug, but also that'll be the same plug for all your solar cells and whatever else you want to charge it with. And that kind of wraps up. We're going to have more videos on more portable power stations as I make them, and we'll carry on doing other things. Any comments, questions, anything like that, leave them down below and I'll try my very best to answer them. And as always, thanks for watching.